Yes, let's talk key exchange. Today we're talking two types of key exchange, symmetric and asymmetric. Symmetric is first, and you're probably already using symmetric key exchange. This is what makes your Wi-Fi work. You have a router from Comcast, Google, Spectrum, whomever offers you your internet service. And there's a key. The key is on the router, but it's also on every device that participates in your Wi-Fi. It could be your wireless doorbell, could be your wireless cameras, could be a $28 IoT light bulb. And yes, I have a $28 light bulb in the next room. Sometimes it works, sometimes not. But getting back to business, though, the symmetric key, also called wireless encryption key, is also on your notebook, your tablet, and your phone or phones. The upside is encryption with this is easy and quick. The downside is that if you need to change this, then you have to change it for every single device, and that can be time consuming. You'd have to change it for your doorbell, and your cameras, and your IoT light bulbs, and your notebook, and tablet, and phones. Could be time consuming. That is the downside with symmetric keys. If you change the key, you have to change the key on every device that connects to that network. Let's move on and talk about asymmetric keys. With asymmetric, we talk about websites that have certificates to help ensure that all the traffic to and from is secure. There's a private key and a public key. The private key is exclusive to whomever runs the website because he who has the private key can read traffic. On the flip side, there's the public key, which is in a certificate. Everybody who visits the website can get the public key and download it automatically. With the public key, you can encrypt, but only somebody with a private key can decrypt. And that is what makes this example work. Last year, I did a train-the-trainer with other trainers who teach this class. And the master instructor asked, what is the most challenging concept? And the overwhelming answer was what we're about to discuss, asymmetric key exchange. So everybody take a deep breath. I'm going to start sharing my screen and we'll talk about asymmetric key exchange. Bob is a human resource consultant. Bob has a website and Bob's security works. It has to work because he's holding people's financial information. Alice is a client. She's the HR manager at a company. And Alice needs to send compensation information to Bob. She needs to send it securely over the internet. Bob has the website. It is secure. Alice visits the website and downloads a copy of Bob's public key. It's in the certificate on its website. Then step 2, Alice takes a file that she needs to send Bob, and she encrypts it with a symmetric key. Then, in step 3, Alice encrypts the symmetric key with Bob's public key. Alice does this because she knows she'll be sending the data over the internet, and she has to make sure that this will not be readable if it falls into the wrong hands. Alice does not know who else is on the internet running Wireshark or some other packet sniffer and looking for information like names, social security numbers, credit card numbers, salaries, wages, compensations, and bonuses. So Alice is encrypting the symmetric key. And the symmetric key is what Alice used to encrypt this. Step 4, Alice sends her message. Step 5, Bob receives the message. Bob uses his private key to decrypt this. Then Bob uses this in step 6 to decrypt this. That is how we send confidential data over the internet. This was the most challenging concept for my peers. So let's look at it another way. Alice is sending this to Bob, her human resource consultant who manages the 401k. Alice gets a public key from Bob. Then Alice uses this asymmetric key to encrypt the payload, the workbook with everybody's compensation. And Alice knows that if this gets out in the public or it gets compromised, then Alice has a new biggest problem. So Alice is encrypting this with this. Alice is sending this over the internet. So what Alice needs to do is encrypt this with Bob's public key. Then Alice sends this on its way. Bob receives this. Bob starts by using his private key to decrypt the symmetric key. Then Bob uses the symmetric key to decrypt the payload, sometimes called the ciphertext. At this point, sometimes people say, why not just use the same key? Well, good question. Symmetric encryption, which you're using on your Wi-Fi, is fast. So that's why we're using it for this. This could be 100 pages long, 1,000 pages long. That's why we're using symmetric encryption here. But we need to keep this secure. That's why we're using asymmetric. Now, asymmetric is a lot slower. But since we're using asymmetric encryption just on this, it's okay. It may add 1 or 2 seconds to the amount of time it takes Bob to open up this message from Alice. Now that everybody's brain is melting, I should pause and ask if everybody's clear, or if you want me to go through this again.